Hello everyone, myself Swapnil Sir and welcome to complete lecture series on vector chapter. As board exam is coming closer, I'm expecting that you all are preparing well. So in my today's video, I'm going to explain to you all one of the very much important topic for our board exam, which is a vector. So which basically near about 8 to 10 marks weightage is there for our board exam. So today's lecture, it is completely based on the some basic topics from the vector chapter, and at the end we will move for some of the previous year questions from the board exam. So I've picked here some of the question which is the latest board exam question papers. Okay, so why we have to solve the previous year question before exam, because at least we'll get an idea which type of the questions are coming in our board exam. Now see that, let me be honest, questions are not getting repeated in your board exam, but the pattern type of the question, it is always getting repeated. So you all need to understand, first of all you all need to have feel about that topic, then any type of the question it comes for this topic, so you are able to solve this one. Okay, so in my today's video I will explain to you all a vector chapter, some of the basic concept of the vector chapter, and at the end we will move for detailed understanding of the concept using previous year questions from our board exam. Okay, so let's start it our lecture. Okay, so in our vector chapter we already know that what is mean by scalar and vector. Okay, those quantity are having magnitude as well as direction, we call it as the vector. Okay, and scalar only the magnitude there. Okay, no any direction available. Okay, this is the just a basic difference between scalar and vector. So we don't have to go for in much detail for this one. So this one is just a recap video. You all need to know a scalar product, dot product for vector, scalar product for vector. Okay, and some of the standard important theorem. Okay, direct direction ratios for line, direction cosines for the line. These are the helpful here for our today's lecture. Okay, so let's start the lecture. Okay, so in our next part of the lecture, what we are going to learn, we learn vector and their types. Okay, vector and their types. How many types are there? Like a dot vector. Okay, there are plenty of the types for our vector. Okay, that we are going to learn this here in under vector and their topic. Okay, types. Okay, now after that we learn we are going to understand the section formula. Okay, so section formula basically it divides into the two parts. Okay, which is first internal division and another one is a external division. Okay, so first section formula we have here, section formula for internal division. Okay, section formula for internal division. Section formula for internal division. Okay, now whenever we have a line which ratio of that line divides internally. Okay, so consider that I'm having the line here. I will explain to you all just some of the basic concept related to section formula, which is for internal division and external division. Okay, yes, here we can see if I consider this triangle, and that is the height for our triangle. Okay, so we have the line AB. Okay, which having a midpoint C. Okay, and the point C divides line AB as the internally in the ratio of a lambda as to take any other coefficient, lambda as to gamma. Okay, or m as to n. So if you feel that take another variable. Okay, so take m as to n. So it divides m as to n. Okay, okay, that m as to n in the internal ratio, these 2 points divides here. And whenever we have 2 points which divides our line segment internally, then we write it's the section formula as a, now see that m into the vector position vector exists here, b bar, n into a bar divided by m plus n as the section formula for our point. Okay, so for internal division we write the section formula m into a bar plus n into b bar divided by m plus n. Okay, so this one is our the section formula for internal division. Okay, so now see that if it is as the coordinate for xy axis, so we have to take the coordinate instead of here as a bar and b bar. Okay, so like a mx bar plus ny bar upon m plus n, and mx plus my plus ny upon m plus n as the coordinate for x axis and the coordinate for y axis. Okay, that's here for our section formula for internal division, that we are going to apply this result subsequently in our examples. Okay, now in our second part, section formula, we need to understand for external division. Okay, external division, section formula for external division. Now here in this case, our midpoint or the point which divides here, which can divides our line externally. Okay, for example, let me draw with the triangle the point which can divides externally. Okay, now see that I am having such a obtuse angle triangle. Okay, now we can see that here I am having obtuse angle triangle, like consider A, B, C. Okay, this one is obtuse angle triangle. Now see that one more point that I consider here, which is the point here. Consider it as the point another point D. Okay, now see that point D which divide line segment BC as a externally. Okay, and whenever we have point which divides line segment externally, so we consider it as the section formula for external division. Okay, section formula for external division. So we write section formula. Now when we have internally, we add their coordinates. Okay, and when we have externally, we subtract their coordinates. Okay, that's it, the difference between internal and external division. Okay, that means m a bar minus n b bar upon m plus n. This one is the section formula for external division, and this one is the section formula for internal division. Okay, these two formulas are very much important here. Okay, in our subsequent part. Okay, so I'm expecting that you all have understood the section formula for internal division and the section formula for external division. Okay, that we are going to apply in our subsequent part. Okay, so after that, dot product of two vectors, cross product of two vectors, triple product of the vectors. So now these 3 points are going to be important for our subsequent example. So whenever the examples are coming here, so I will explain these points while solving the examples. Okay, so if I'm going to explain that topic point here, it will be time taking and confusing to understand. Okay, so if you prepared this point properly, I don't think so next further part is difficult to you all. Okay, now let's get start our today's lecture, which is a lecture completely based on previous year question from the 12th board exam. Okay, so I have considered here the questions only from the multiple choice questions. Okay, in our board exam we have multiple choice question for 2 marks. Okay, and the question answer for these questions are coming in only 1 or 2 steps. Okay, not that lengthy question, just need to apply single concept and then you will get the required answer. Okay, nothing is difficult here. Okay, now let's get start our today's lecture with one of the previous year questions from the board exam. So I plan to take only the question from the latest question paper. Okay, now see that I have here first question which asked in March 2013 board exam, which asked in March 2013 board exam for 2 marks. Okay, question asked in March 2013 board exam for 2 marks, and question it says that if the vectors are here, we have the vectors here minus 3i plus 4j minus 2k, second vector I plus 2k, third vector I minus pj, and that these 3 of the vectors are coplanar. Okay, that means we have given 3 vectors and these 3 vectors are the coplanar. Then we want the value for p. Okay, so we need to understand first of all what is mean by coplanar vector. Okay, so generally if we take the meaning for coplanar vector, that means the vector which comes under single plane. Okay, we consider it as the coplanar vector. But there is a mathematical way to solve this question. Okay, to attempt this question we have mathematical way. That means we have to show the determinant for these three vectors, it needs to be a 0. Then we consider it as these vector are a coplanar vector. Okay, now I have vector first, second and third. Okay, so if these three vectors are coplanar, that means we have to show one standard result of that determinant needs to be a 0. Okay, now let me explain the result to you all first, and then we'll proceed with the solution. Okay, now we can see here I'm writing the result. If I'm having the vectors like a bar, which is equal to, so I consider the vector a bar because I wanted to explain to you all here the general result that is useful for finding the today's solution, that example solution. Okay, so a bar I consider here minus 3 times I bar. Okay, I cap, it is already there. So I'm writing, I'm designating all these variables, sorry, all these vectors with some certain names. Okay, so minus 3i plus 4j minus 2k minus 3i plus 4 times j, okay, minus 2 times k. Okay, these are the this is our first position vector. Let's go for the next vector b bar. Consider it is, I named them only as a bar, b bar, c bar. Okay, now b bar, it says that I bar, okay, I bar, okay, no, I don't, we do how to take this vector in the form of determinant. Okay, first of all write down the what we have given, b bar which is equal to I bar plus 2j, the term for 2j which is absent in our question. Okay, the term for 2j which is not present in our question. So what we do here, we consider j term as a 0 times j. That means our equation, it will remain same, and our required condition for a j, it will be appear in our equation. Okay, so we write it I plus 0 times j I cap plus 0 times j cap plus 2 times k cap. Okay, so this is the position vector b bar. Now let's move for the position vector c bar. Okay, so I consider position vector c bar I cap minus p times j cap. Okay, now see that we don't have the term for k cap. Okay, so in such a case what we do, we consider it is as a 0 times k cap. Okay, plus 0 times k cap. Okay, because we want the term coefficient for k cap in our determinant, that's why I consider it as the 0 times k cap. Okay, I'm expecting you will have understood how I have written this one. So all these things are given in our question. Okay, and these three position vectors are coplanar. Okay, these three position vectors are coplanar, and if the position vectors are coplanar, then we write their coefficient in the form of a determinant, and that determinant needs to be a 0. Okay, now let me define the determinant for this position vector. Okay, if vectors are coplanar, okay, let me write the condition, vectors are a coplanar. Okay, if the vectors are coplanar, then we write their determinant is equal to 0. Okay, determinant of these three vectors is equal to 0, but the determinant of this vector we write as their coefficient of I, j and k. Okay, now let me define here the determinant for our vector. Now see that first row, entire row, it goes for the coefficient of I cap. Second entire column, it goes to the coefficient of a j cap, and third entire column, it goes to be the coefficient of a k cap. Okay, so write down their coefficient of I cap minus 3, 1, again 1. Okay, these are the three coefficient of I cap. Similarly, the coefficient of a j cap appear here as a second column. 4 0 minus p, 4 0 minus p. Okay, here 4 0 minus p, and the third minus 2 2 0, minus 2 2 0. Okay, this one is the coefficient for I cap, j cap, k cap from our position vector. Okay, okay, that means this one is the coefficient for this one is the I cap coefficient, this one is the j cap coefficient, and this one is the k cap coefficient. Okay, so this one is our the coefficient for I cap, second coefficient for j cap, and third coefficient for k cap. We have a general formula for this one, so I'm not writing this formula because it's a time taking, but I explain all this formula in the form of example. Okay, now see that if these three vectors are coplanar, okay, already it is given condition in our example. Okay, if these three vectors are coplanar, then we write its a determinant equal to 0. Okay, this is the standard condition. If these three vectors are coplanar, then we write their determinant equal to 0. Okay, so if it is determinant equal to 0, then go for the further calculation and find out the answer. Okay, okay, this is the condition for coplanarity. Okay, okay, now let's go for the finding determinant. Okay, I'm expecting the determinant for finding the determinant of this 3 by 3 matrix. It is easier. Okay, and if you don't know how to find the determinant, 2 by 2 determinant, 3 by 3 determinant, you may do check in my playlist. You will get the entire video there. Okay, okay, so go for the finding the determinant. So minus 3 under bracket 0 0 is 0, minus of a 2 times of negative of a 2p it comes. Okay, so p negative of a p multiplied by 2, which is a negative of a 2p, and a minus of a minus 2p, it gives us plus 2p. Okay, again next minus 4. Okay, minus 4, because we take alternate sign for finding the determinant. So if I consider here this one is a plus, this one minus. Okay, this one plus, this one minus, plus minus, while we are solving our determinant. Okay, so minus 3 into first 2 by 2 determinant, minus 4 into second 2 by 2 determinant. So 1 into 0 0, minus 1 into 2 2. Okay, so we write the 0 minus 2. Okay, and the next minus 2. Okay, we consider third as the positive, but already third term it is given as a negative. So plus multiplied by minus, we write it as the minus. Okay, so we write a minus of a 2 under bracket 1 multiplied by minus p, it gives a minus p. Okay, and 1 multiplied by 0, which is a negative of a 0. Okay, and which is equal to entire value for this determinant equal to 0. Okay, and let's go for the further calculation. So minus 3 multiplied by 2p. Okay, that means 3 2s are minus 6. Okay, so it gives us a minus 6p. Okay, so minus 4 multiplied by minus 2, so plus 8 it comes. Okay, so minus 2 multiplied by minus p, so it gives us a plus 2p, which is equal to 0. Okay, this is just a simplified form of our given step. Okay, go for finding the next values. So minus 6p plus 2p, so it gives us minus 4 times p plus 8, which is equal to 0. Okay, so we write this term as a 4p, which is equal to 8, and then p gives us 8 divided by 4. That means the value for p, which is required value for p, is a 2. Okay, and now see that how easy questions are coming in our board exam. Okay, nothing is difficult here. We just have to apply the condition for coplanarity. Okay, if the vectors are coplanar, then we write their determinant as a 0. Okay, so I'm expecting you all have understood the solution for this example. Question asked in March 2013 for 2 marks. Okay, so this type of the examples helps you to make score higher in your board exam. So always solve this example first. Okay, so now let's go for the next question. I'm expecting you all have understood my previous question. Okay, now in our next question, question asked in October 2013 for 2 marks. Okay, question it is from October 2013 for 2 marks. And the question it says that if a line inclined at a 60 degree and a 30 degree, okay, so if we have given inclination of a line, okay, the inclination of a line which given 60 degree and 30 degree with the x-axis and y-axis, okay, with the x-axis and y-axis. Now let me write what we have given. Okay, we have given the line inclined. Okay, we have given line inclined at 60 degree and 30 degree. Okay, line inclined at a 60 degree and a 30 degree with x and y axis. X and y with x and y axis. Okay, this one is given. That means the inclination of a line with the x axis is a 60 degree, and the inclination of a line with the y axis is a 30 degree. Okay, now we have two different angles, so name it some another variable like alpha, beta, gamma. Okay, so why? Because we are getting this calculation in the easier form. So the inclination of a line with the x axis, okay, now see that 60 degree and 30 degree with the x axis and with the y axis. That means x axis is having inclination of a line which is a 60 degree. For x axis, okay, we write for x axis, okay, we write for x axis, consider it as the alpha as a 60 degree. Okay, so I consider x axis, the inclination of a line, as a x axis alpha which is equal to 60 degree. Similarly, for inclination of a line with a y axis, I consider it as the beta. Okay, and beta which is equal to 30 degree. Okay, so I found the value for alpha and beta, which is the inclination of a line with x axis and a y axis. Okay, so I'm having this value, and what we want here, then we want the angle which makes with the z axis. Okay, then that means we want the inclination of angle which comes from the z axis. Okay, x axis already given, y axis given. Using this, we want the inclination of a line with a z axis. Okay, no, now we know that whenever we have three lines, okay, inclination of three angles, okay, with x axis, y axis and z axis, then we write the result for inclination of a line as, okay, cos square alpha plus cos square beta plus cos square gamma, which is equal to 1. Okay, this one is the inclination of a line when we have line inclined with the x axis, y axis, z axis. Okay, and for finding the third angle, we can see that we have one angle here, another one here, and we have to find out the third one. Okay, now what we do here now, substitute that alpha beta here, so you can get the third value for gamma, and which is the inclination of a line with the z axis. Okay, now let me write here the inclination of with the z axis as a, for z axis we write for z axis as gamma. Okay, and we want the value for gamma here. Okay, the inclination of a line with the z axis, I consider here gamma, and we want the value for gamma. Okay, that means we want this value for gamma. Okay, now see that we have the value for alpha. Okay, so substitute, put alpha which is equal to 60 and beta which is equal to 30. Okay, put these two values here, so you will get the required answer. Okay, so put alpha which is equal to 60 degree and beta which is equal to 30 degree. Okay, in our given example. Okay, now see that, not a given example, with this result. Okay, put the value for alpha beta in our result. Okay, now see that alpha is a 60, that means cos square 60. So we write a cos square of a 60 degree, okay, cos square of a 60, plus beta is a 30, that means a cos square of 30, okay, plus cos square of gamma, okay, which is equal to 1. Now see that I'm having the value for alpha 60, beta which is a 30. I substitute these values in our result. Okay, now let's go for finding the further calculations. Okay, before I go for further calculation, you all need to know cos square of a theta. You may take any trigonometric identity. Okay, cos square of a theta can be written as cos theta entire bracket square. Okay, so these two quantity mean same. Okay, that means cos square of theta and cos theta square both are having equal values. Okay, so that means here what we want the cos square of a 60. That means we write as the cos of 60 entire bracket square, okay, plus sin cos square of a 30. That means we also write this one as cos 30 entire bracket square, okay, plus cos gamma entire bracket square, which is equal to 1. Okay, so what I have done, I just written their cos square of a theta as a cos theta bracket square. And why I have written, because it is easier to find out the value for cos 60. Okay, so the value for cos 60, which is a 1 by 2. Okay, you all need to know the cos 60, we have value 1 by 2. Okay, what is the value for cos 60? 1 by 2. And after that we want the cos 30. Okay, cos 60 and cos 30 we have root 3 divided by 2. Okay, these two values you all need to know. And if you don't know, how can we remember the trigonometric values? Okay, you may do check it out in my playlist. You will get these answers. Okay, so I explained these terms with the short trick and given some of the result here that you can understand it well. Okay, let's go for the next calculations. Okay, so cos 60 bracket square, that means cos 60 having value 1 by 2, that means 1 by 2 bracket square, plus cos 30 we have value cos 30 is a root 3 divided by 2 bracket square, plus cos gamma bracket square, which is equal to 1. We cannot do anything with this value of cos gamma. Okay, because the cos gamma, the value for gamma we want here. That's why I'm keeping that cos gamma as it is here for our further calculation. And now see that we have 1 by 4. 1 by 2 bracket square means numerator square as well as denominator square. So we get the 1 divided by 4 plus root 3 square, which comes 3. 2 square it comes 4. Okay, plus cos square of gamma. Okay, cos gamma square or cos square of gamma both are the similar. Okay, so let me write with the above form. We write as the cos square of cos gamma bracket square, okay, which is equal to 1. Now 1 by 4 plus 3 by 4, as we have denominator 4 same, take it once and add their numerator. So numerator addition 1 plus 3 4 and 4 by 4, which is a 1. Okay, so 1 plus cos square gamma, we get the 1. Okay, so next step we write 1 plus cos square gamma, which is equal to 1. Okay, take that 1 to the other side. Take this 1 to the other side, we get the cos square of a gamma, which is equal to, take its a bracket square. Okay, so cos square of a gamma. So we have taken cos of a gamma bracket square. We have taken this one. Okay, now see that in our next step, plus 1, if we take it to the other side, we'll get the 0. Okay, so 1 minus 1, it comes the 0. Okay, so I got the value cos square gamma, which is equal to 0. Okay, now tell me the value for cos square gamma when it goes to 0. So we write this one as a cos gamma bracket square, which is equal to 0 times square. Okay, that means cos gamma we can write it as the 0. Okay, the cos gamma, which is equal to 0. Okay, when cos it goes to 0. Now see that sine goes to 0 at origin, cos goes to 0 at imaginary axis. Okay, that means it goes to pi by 2, and the value for cos gamma, which is a 3 pi by 2. Okay, now see that we have the possible value for cos gamma which goes to 0 as a pi by 2 only. Okay, so I consider here the cos gamma which is a pi by 2, and now we have two all values when cos goes to 0, pi by 2, 3 pi by 2, but we don't have to go for the 3 pi by 2 as we don't have option as a 3 pi by 2. We have the option only pi by 2 here. Okay, that's why we are taking only the value for cos gamma, then cos we write it as the cos pi by 2 which is equal to 0. Okay, if cos pi by 2 0, then we got the value for gamma which is equal to pi by 2. Okay, so this one is our required answer for our example. Now see that how easy questions are there. Okay, just you need to know the one result for finding the inclination of a line, which is the cos square alpha plus cos square gamma plus cos square beta, which is equal to 1. So already I given proof of this entire statement. So if you wanted to see, do check it out. Okay, in my playlist. Now let's move for the next example. I hope you all have understood this solution. Okay, next example, we have given which of the following represent direction cosine of the lines. Okay, so we have given the value for vectors. Okay, and we have to find out which of the following represent direction cosine of the line. Okay, so you all need to know what is the direction cosines and what is the direction ratios. Okay, okay, so what we have given, we want the direction cosines of the lines. Okay, let me change the color. We want the direction cosines of the line, direction cosines of the line. Okay, so we want the direction cosines of the line. So no, we already have given direction cosines. We have in separate 4 option, we have given 4 direction cosines, and we just have to verify whether this direction cosines of the line or not. Okay, so we have to find out the direction cosines of the line using our 4 given options. Okay, and we know that if any term it represent direction cosines, then it has to satisfy that cos square alpha plus cos square beta plus cos square gamma which is equal to 1, or we consider cos alpha as a L, cos beta as a m, cos gamma as a n. That means we have to show here L square plus m square plus n square which is equal to 1. Okay, that means we have to show the value for L square plus m square plus n square which is equal to 1. Okay, the value for L square, we know that the value for L which is a cos alpha, m which is a cos beta, and n which is equal to cos gamma. Okay, so we have the value for L, m, n as a cos alpha, cos beta and cos gamma. Okay, that means L square means cos alpha square, m square means cos beta square, and n square means cos gamma square. Okay, so these 3 values we have here. That means write L square plus m square plus n square which is equal to 1. That means the value for cos alpha we have here 0. That means it is some constant value for our theta. Okay, whenever we apply some theta to our cos, we will get the answer in this format: 0, 1 by root 2 and 1 by 2. Okay, in this format we will get the answer. Now see that L which is equal to cos alpha, m cos beta, n which is equal to cos gamma. Now pick any of the option and verify whether L square plus m square plus n square which is equal to 1 or not. Okay, so we are going to apply L square plus m square plus n square which is equal to 1 as a part of our result. Okay, and now we are going to consider from option A. Okay, so let's consider as option A. So our option A, it gives us 0, 1 by root 2 and 1 by 2. Okay, now see that go for finding the values for L, m, n in our required result. Okay, so we have the value for L which is a 0, again m which is equal to 1 by root 2, and n which is equal to 1 by 2. Okay, yes, Now what we do? Put all these values in our L square plus M square plus N square. That means L square means 0 square plus M square means 1 by root 2. 1 by root 2. M square means 1 by root 2 bracket square. Okay. Let me write this one again. Yes. L square means 0 square plus M square means 1 by root 2 bracket square plus N square means 1 by 2 bracket square. Okay. And which gives us the value 1. Now see, verify both sides are coming equal or not. And if both sides are coming equal, then we say that given direction ratios are value for LMN as the direction cosines of the line. Okay. These are the direction cosines of the line when it satisfies L square plus M square plus N square, which is equal to 1. Okay. Yes. Now 1 by root 2 square, we can write 1 square as 1, root 2 square as a 2, plus 1 by 2 square, 1 divided by 4. Okay. Now go for the next calculation. We have to find out whether it comes 1 or not. Okay. 1 by 2 means 2 by 4, 2 plus 1, 3 by 4. Okay. So we'll get the 3 by 4, which not equal to 1. Okay. So which not equal to 1. So that means our first option discarded here, that it cannot represent direction cosines of the line. Okay. Now similarly verify for option number B. Okay. Option B gives us 0 minus root 3 divided by 2 and 1 by root 2. Okay. 1 by root 2. Now we have to verify whether it represents direction cosines of the lines or not. Okay. Now value for L, which is a 0, value for M, which is equal to negative of root 3 by 2, and value for N, which is a 1 by root 2. Okay. Put this value in L square plus M square plus N square, which is equal to 0. L square means 0 square plus M square means negative of root 3 divided by 2 square plus N square means 1 by root 2 square. Okay, which is equal to 1. Okay, so the L square plus M square plus N square, which is equal to 1. Now verify whether these two sides are equal or not. Okay, so 0 square, it always goes to 0. No need to write this one. Okay, negative root 3 square. Okay, negative of root 3 square, that means negative of root 3 square, it gives us only 3. 2 square, it goes to the 4. Okay, so 3 by 4. 1 by root 2 square means 1 square, which is a 1, root 2 square, which is a 2, which is equal to 1. Okay, so make their denominator same. So we write a 3 by 4 plus 2 by 4. Okay, I multiply 2, divide 2 in order to make their denominator same. Okay, so for further calculation it is easier. Okay, so which is equal to 1. Now see that 3 plus 2, which is a 5 by 4, 5 by 4, which not equal to 1. Okay, so our next option which also be wrong here. Okay, because it cannot satisfy L square plus M square plus N square, which is equal to 1. Okay, let's go for the option C. 0 root 3 by 2, 1 by 2. Okay, 0 root 3 divided by 2 and 1 by 2 are the three okay, we have to show whether these three are direction cosines of the lines or not. Okay, now let's go for the L square plus M square plus N square. That means L square means 0 square plus M square means root 3 divided by 2 square plus N square means 1 by 2 bracket square, which is equal to 1. Okay, so root 3 by 2 square means 3 divided by 4 plus 1 by 2 square means 1 divided by 4, which is equal to 1. Now see that denominator same, so we take it once. 3 plus 1, which is a 4 divided by 4, which is equal to 1. So we write it as the 1 divided by 1 is 4 divided by 4 as a 1. Okay, now it gives us 1, which is equal to 1. Now we can say that our option number C, which is a 0 root 3 by 2 and 1 by 2, which represent direction cosines of the line. Okay, so it is a single correct answer, so we don't have to check fourth option whether it is correct or not. Okay, and if you wanted to practice more, you may go for the fourth option. Okay, that question asked in March 2014 board exam for 2 marks. Okay, I'm expecting that you all have understood. Let's move for the next example. In our next example, we have given direction cosines of the line passing through the point. Okay, we have given direction cosines of the line passing through the points. We have given direction cosines. Write down the direction cosines of the line. Direction cosines of the lines, direction cosines of the lines passing through point, passing through point, some points are given. Point A, which is equal to -4, 2, 3. Okay, these are the point of A, and a point B given 1, 3, -2. Okay, point A and point B given, and we have to show direction cosines of the line passing through the point. Okay, so we have given 2 points and we have to show direction cosines of the line passing through these points. What are the direction cosines of the line? Okay, now let's go for the solution for this example. Question asked in March 2014 board exam for 2 marks. Okay, then here we have given A -4, 2, 3, B 1, 3, -2. For finding the direction cosines of the line, what we do, first of all, we go for LMN or direction cosines of the line. Okay, if LMN are direction cosines of the vector R bar and ABC are the 3 numbers such that L by M, L divided by M, M divided by B and N divided by C are the direction cosines. Okay, then we write direction ratio of the line R bar and we write it as the L as a, let me write the value for L M N. Okay, we write L as the A upon square root of A square plus B square plus C square. Okay, A divided by square root of A square plus B square plus C square. Okay, M can be written as B upon square root of A square plus B square plus C square, and we write N as the C upon square root of A square plus B square plus C square. Okay, so we want the value for here A, B, C, and the A, B, C represent here direction ratios. Okay, so A, B, C represent here direction ratios. Now what we have, the point A and point B. The point A having first coordinate -4, point B is having first coordinate 1. Okay, then its a direction ratio, we write this minus the first coordinate 1 minus first coordinate of point A. Okay, so if we have point AB, then for finding the direction ratio as A, B and C, what we do, we subtract first coordinate from first coordinate, second coordinate from the second coordinate, and third coordinate from the third coordinate. So you will get the direction ratios of the line. Okay, and substitute this value A, B, C in our result. Okay, now here we have challenging part to find out the value for A, B and C. Okay, so once you get the value for A, B, C, just leftover part is just for substitution. Okay, for value of A, for finding the value of A, for finding the value of B, and for finding the value of C. Okay, we go, let me change the color. Yeah, for finding the value of A, so what we do, 1 minus -4. Okay, 1 minus of -4, this one is the first value for A. Okay, as we consider it as a direction ratios. Okay, for finding the direction ratio between line A and B, so we take first coordinate minus first coordinate, second coordinate minus second coordinate, that means 3 minus 2, third coordinate minus third coordinate, minus 2 minus 3. Okay, so these 3 are the direction ratios for our line, and if we have 3 direction ratios, then put these values in our here, then you will get the direction cosines of the line. Okay, you first of all you have to understand what is meant by direction ratio and direction cosines. Okay, for finding the direction cosines, we need L square, M square, N square, or L, M, N. Okay, for finding direction cosines. And for finding the direction ratios, we just have to take the difference between our 2 points. Okay, like a point B and point A. So 1 minus -4, it gives us +5. 3 minus 2, which gives us 1, and -2 -3 which gives us -5. Okay, so that means the value for A, which is the value for A, again which is the value for B 1, and which is the value for C. Okay, so I got the value for A, the value for B, and the value for C. Substitute all these value in our L, M and N, you will get the required answer. Okay, so L, which is equal to A divided by, what is the value for A, which is a 5. Okay, 5 divided by square root of A square. A square means 5 square, which comes 25, plus a B square. B square means 1 square, it remain 1, plus C square means negative of 5 square, it goes to the 25. Okay, yes, so 5 divided by 25 plus 1 plus 5. Okay, so this is the value for L. Again similarly find out the value for M. Okay, M, it says that B divided by square root of A square plus B square plus C square. The value for B, which is a 1, completely divided by square root of A square B square C square. It is same everywhere in our denominator, so take these values as it is. So 25 plus 1, A square 25, B square 1, and C square, which is a 25. Okay, so this is the value for M, and again find out the value for N. N, which is a C upon A square plus B square plus C square. Okay, and the value for C, which is a negative 5, divided by A square plus B square plus C square, which is a 25 plus 1 plus 25. Okay, this is the value for A square, B square, C square. Okay, so value for L, which is equal to 5 divided by under square root 25 plus 25, 50 plus 1, 51. So under square root we get the 51. Value for M, 1 upon square root of 51, and the value for N, we write it as the -5 upon square root of 51. Okay, now check it out which one of the option is correct. Okay, so we can see that L square. Okay, so we want the L square, M square and N square. Okay, so for finding their values, L, which is equal to A upon A square plus B square plus C square upon plus M, which is equal to A upon A square plus B square plus C square. Okay, so for finding the direction ratio, so it is as the L, which is equal to A square upon A square plus B square plus C square, it is there. Whenever we take the square root, it gives us the plus minus sign. Okay, don't forget to write this plus minus sign. Okay, this one is the plus minus sign. That means if L, which is equal to some number L, which is equal to A, then if we take the square root for this number, so we can write L, which is equal to plus minus A. So similar condition here. So we write this one is in the form of plus minus, this one is in the form of plus minus, and this one is also in the form of plus minus. Okay, plus minus multiplied by minus, so we get the minus plus. Okay, it's the reverse value. Okay, now we can see that we got the L as a plus minus 5 by root 51 as a option B. Okay, second option M is equal to plus minus 1 by root 51, it is correct here, and third option plus minus minus 5 by root 51. So our required option, it gives us option number B. Okay, so I'm expecting you all have understood the solution for my entire example. Okay, nothing is difficult, we just have applied the direction cosines and direction ratios results. Okay, let's move for the next example. Yes, so we have given in next example, we have given A bar, B bar, C bar. Okay, we have given vector A bar, B bar, C bar, which is equal to non-zero. Okay, and a P bar, it is written. Okay, so let me write the solution here further. So we have given A bar, B bar and C bar, vector A bar, B bar, C bar, which not equal to 0. Okay, and P bar can be written as B bar cross C bar divided by A bar, B bar, C bar. Okay, P bar written as B bar cross C bar divided by A bar, B bar, C bar. Again Q bar, it is given as C bar cross A bar divided by A bar, B bar, C bar. Okay, P, Q, and also R, it is given. Okay, R is given as A bar cross B bar. Okay, divided by vector A bar, B bar and C bar. Okay, and then we want the value for A, we want the value for A dot a bar dot p bar plus b bar dot q bar plus c bar dot r bar. Okay, we want the value for a bar dot b bar dot q bar, and plus c bar dot r bar. Okay, now put all these values in our given equation that we have to simplify it further. Okay, so a bar dot p bar. Okay, a bar dot p bar, that means we write it as the a bar dot value for p bar, b bar cross c bar. Okay, so divided by a bar, b bar, c bar. Okay, so I written a bar dot p bar as a bar dot b bar cross c bar upon a bar b bar c bar. Okay, plus b bar dot q bar. So we can write b bar dot, the value for q bar is a c bar dot q bar, c bar dot a bar. It is not the q bar. Okay, this one is the value for a, c bar dot a bar. Okay, c bar cross a bar divided by a bar, vector a bar, b bar, c bar. Okay, so it written as this, like this way. And third one, c bar dot r bar. Okay, c bar dot r bar means put the value c bar dot value for r bar, a bar cross b bar. Okay, a bar cross b bar, and completely divided by a bar, b bar, and c bar. Okay, these are the three values. We have to find out the answer for three values. Okay, so what we do, let's go for finding the further steps. Now as we know that a bar dot b bar cross c bar can be written as a bar dot b bar cross c bar can be written as, now let me write the result, a bar dot b bar cross c bar in the vector form. A bar dot b bar cross c bar can be written as a bar b bar c bar. Okay, so that means both are having same meaning. Okay, so we use this result for finding the next calculation. Okay, now substitute these values here. A bar dot b bar cross c bar can be written as a bar b bar c bar. Okay, and completely divided by a bar b bar c bar. Okay, okay, plus b bar dot c bar cross a bar. Okay, and one more, we know that a bar dot b bar cross c bar, which is equal to, so there is a cyclic product for these vectors are always equal. That means a bar dot b bar cross c bar, b bar dot c bar cross a bar, which is equal to c bar dot a bar cross b bar. Okay, all are equal here. All these cyclic product of the vectors are equal. Okay, so that's why I can write all them as a bar dot b bar cross c bar. So all the value are equal to a bar dot b bar cross c bar, and a bar dot b bar cross c bar can be written as a bar b bar, vector a bar b bar c bar. Okay, so we write a vector a bar b bar and c bar, completely divided by vector a bar b bar and c bar. Okay, plus third vectors c bar dot a bar cross b bar, which is equal to a bar dot b bar cross c bar, and a bar dot b bar cross c bar can be written as a bar b bar c bar. Okay, so a bar b bar c bar completely divided by a bar b bar c bar. Okay, now see that we have denominator same, numerator same. If we cancel them together, so we'll get the value 1 plus, we'll get the value 1 plus we get the value 1 here. Okay, so if we add all of them, we get the required answer as a 3. Okay, so our option number D, which is correct here. Okay, so which gives us answer 3. Okay, I'm expecting you all have understood this solution. Let's move for the another. Okay, so we have given if the vectors 2i minus qj plus 3k. Okay, first vector given, first vector given 2i minus qj plus 3k, 2i cap q minus qj cap plus 3k cap. Okay, first vector given. Now let's go for the second vector. For I cap minus 5 times j cap plus 6 times k cap. Okay, we have given first vector and second vector. Okay, and these two vectors are collinear. Both are collinear. Okay, both are the collinear vector, and if we have the collinear vector, then how can we write this collinear vector? We write their determinant. Okay, so we take their determinant or we take their ratio. Okay, so we'll go for that ratio later. And what we want here, the value for q, we want the value for q. Okay, we want the value for q here. For finding the value for q, we need to know, we can write their ratio for our vector. Okay, and their ratio can be written as, direction ratios can be written as first vector divided by second vector, which is equal to first coefficient of I cap divided by first coefficient of I cap, which is equal to second coefficient of j cap, first coefficient of j cap divided by second coefficient of j cap, and which is equal to first coefficient of k cap, which is equal to third coefficient of k cap. Okay, so if we have two different vectors given, then we can take them in the form of a ratio if and only if they are collinear vector. Okay, so if we have collinear vector, then we write 2 divided by first ratio 2 divided by 4, okay, which is equal to minus q divided by minus 5, minus q divided by minus 5, and third vector 3 divided by 6. Okay, this one is a q. Okay, minus q divided by minus 5 and 3 divided by 6. Okay, we just have to find out the calculations, compare any of the two terms. Okay, 2 by 4 which is equal to minus q divided by minus 5. Okay, and 3 by which is equal to 3 by 6. How I have written? Because these three vectors are collinear, and vectors are collinear, we can take their reciprocal or ratio as a coefficient of first I cap, coefficient of j cap, and coefficient of k cap in the form of a ratio, and they are equal. Okay, so 2 divided by 4 we can write it as the 2 divided by 4 which is equal to minus q divided by minus 5. Okay, that means a which is equal to b which is equal to c means a which is equal to b and b which is equal to c and a which is equal to c. Okay, this relation we have to use here, a which is equal to b which is equal to c, meaning for these three equal terms we write a which is equal to b, next b which is equal to c, and we write a which is equal to c. These three terms are equal. Okay, so what we do here, go for the comparing one of the terms, so you will get the required answer. Okay, 2 divided by 4 we write it is 1 by 2, minus q divided by minus 5 we write as the q divided by 5. Okay, take 5 to the other side, so you will get the q as a 5 divided by 2, which is our required answer. Okay, which is a 5 by 2, option number C. Okay, now see that answer, it is coming only in a 2 to 3 steps. Nothing is difficult, just need to apply some of the basic definitions from the vector chapter. I hope you have understood this solution. Okay, let's move for the next example. Okay, all are the questions from multiple choice question which asked in July 2016 board exam for 2 marks. Okay, let's move for the next example. Okay, so we have the points. Okay, a 2 1 1, b 0 minus 1 4, and c k 3 minus 2. Okay, point a given 2 1 1. Okay, 2 1 1. Point b given 0 minus 1 4, and a point c given 0, so point c given k 3 2 is there. Okay, and a point c we have given k 3 minus 2. Okay, okay, are collinear. Okay, are given. Okay, these 3 points are given collinear. Okay, and we need to know condition for collinearity, and at the end we want the value for k. Okay, we want the value for k here, and the condition for collinearity, it says that if the 3 vectors are collinear, then we write direction ratios for AB bar, direction ratios for BC bar, and then we take their reciprocal. Okay, so direction ratios for AB bar we write it as the, as earlier I have explained here, direction ratios for AB bar, DRS of direction ratios of AB bar. Okay, we want the direction ratios of AB bar, and the direction ratios of BC bar, we want the direction ratios of BC bar. Okay, we want these two direction ratios, AB bar and BC bar. Okay, so for finding the direction ratios of AB bar, what we do, we subtract first variable of B bar with the first variable of A bar. Okay, that means 0 minus 2 first here, again minus 1 minus 1 minus 1 minus 1, next 4 minus 1 4 minus 1. So 0 minus 2 gives negative 2, minus 1 it gives negative 2, and 4 minus 1 it gives 3. These are the direction ratios of our line AB bar. Okay, similarly find out the direction ratios of the line BC bar. Okay, so BC bar means K bar minus 0 bar, first direction ratios here, first here, second here, third here. Okay, for the AB bar. Similarly for BC bar, find out first, second, third, three direction ratios. Okay, first position vector minus first position vector. Okay, first coefficient of position vector K minus 0. Okay, so K minus 0 first, again 3 minus minus 1, 3 minus minus 1 second, and third minus 4 minus 2 minus 4. Okay, minus 2 minus 4. These are the direction ratios for our line. Okay, so K minus 0 can be written as only K. Okay, 3 minus minus 1 can be written as 4, and minus 2 minus 4 can be written as minus 6. Okay, now see that I got the direction ratios for AB bar, direction ratios of BC bar. Okay, okay, now we can say that we can take the reciprocal for the direction ratios of AB bar and BC bar. So in order to find out the value for K, okay, if these three vectors are collinear, okay, if these vectors are collinear, then we take their reciprocal. Okay, for direction ratios of AB bar and direction ratios of BC bar. Okay, so how can we take their reciprocal? Okay, reciprocal can be written as first vector divided by first vector. So K divided by minus 2, which is equal to 4 divided by minus 2, which is equal to minus 6 divided by 3, minus 6 divided by 3. Okay, so compare all of them, and we know that you can take this one equal to this or this one equal to this. Okay, so K, we compare first to K divided by minus 2, which is equal to 4 divided by minus 2. Okay, so minus 2 can cancel, so we get the K which is equal to 4, which is our required answer for K. Okay, so which given in our option number C. Now see that question asked in March 2017 board exam for 2 marks. I'm expecting you all have understood this one. Okay, okay, this one is the last example, that we want the A bar dot B bar cross C bar. Okay, okay, so we have given vector, let me write the vector. Vector we have given A bar, which is equal to 3 times I cap minus J cap plus 4 times K cap. Okay, vector B bar given 2 I cap plus 3 J cap minus K cap. Okay, and vector C bar given minus 5 times I cap plus 2 times J cap plus 3 times K cap. Okay, so we have given 3 vectors, A bar, B bar, C bar. Okay, and then we want the value for A bar dot B bar cross C bar. Okay, we want the value for A bar dot B bar cross C bar. Okay, for finding the value for A bar dot B bar cross C bar, we know that we take their coefficient of A bar, B bar, C bar. Okay, so that means A bar dot B bar cross C bar can be written as A bar, B bar, C bar, and we can write it is the determinant for coefficient of I cap here, coefficient of J cap here, and coefficient of K cap here. Okay, so we can write the coefficient of I cap, J cap, K cap in the form of a determinant. Okay, now put these values here. Okay, so as we want A bar dot B bar cross C bar, substitute the value there. Okay, so we'll get the answer. So A bar dot B bar cross C bar can be written as A bar B bar, A bar B bar C bar. Okay, and this one can be written as in the form of a determinant, coefficient of I cap in entire column. So 3, 2, minus 5. Okay, second coefficient J minus 1, 3, 2, third coefficient of K 4, minus 1 and 3. Okay, so this one is our determinant. Okay, so the value for determinant we have to take the coefficient of I cap entire here. Okay, this one is the coefficient of I cap, this one is the coefficient of J cap, and this one is the coefficient of K cap. Okay, and subsequent part, what we do, we go for finding the determinant of our matrix. Okay, so how we can find the determinant? Go for the next calculation. 3 common here, multiply 3 3s are 9, minus of -2 plus 2. Okay, so this is just solving out 2 by 2 determinant. Negative of -1, so we get the +1 under bracket, 2 3s are 6, minus -5 into -1, which is a +5. Last plus 4 remain here, take with the 4, 2 2s are 4, minus 5 3s are 15, so -15, which comes a +15. Okay, so 9 to 11 3s are 9 to 11, 11 3s are 33. Okay, plus 6 minus 5, 1 1s are 1, plus 4 15s are. Okay, 15 4s are 60, 4s are. Okay, 60 multiplied by 4. Now see that 15 plus 4, sorry, it is 19. Okay, not a multiplication. 15 plus 4 19, and 19 multiplied by 4. Okay, so we write 19 multiplied by 4, it gives us the 76. Okay, and when we add all of these values, we will get the answer. Add all of them, you will get the answer 110. Okay, which is the required answer, which is from the option number C. Okay, I'm expecting that you all have understood the solution for this example. We just have to apply some basic result in order to solve these multiple choice questions. Okay, nothing is difficult here, and even after, if you found anything difficult, let me know in comment section. Okay, now let's go for a little recap about what we have done in our today's example. Okay, we have started vector chapter. Okay, so multiple choice question. First we learn the dot product, cross product, section formula for internal division, section formula for external division. Okay, internal and external. Okay, section formula for internal division, section formula for external division, direction ratios for line, direction cosines for line. Using the two different vector, how can we find the direction ratio, how can we find the direction cosine? All these terms we learn in our today's lecture. Okay, so I'm expecting that you all have understood my today's complete lecture. Even if you found anything difficult, let me know in my comment section. I will come up with the similar videos. Okay, and if you want more video, do also comment me, because I also wanted to know what you found difficult. I will come up with the similar videos that can make your difficulty away. Okay, so thank you everyone. Thank you for my today's lecture.